In this section, we are going to be talking about composite functions. I'm going to be working on just this first odd problems, and this way you can kind of try it with the even ones to get some practice. So first up, we have f of g of x, which can also be written as f of g of x right here. You do have to know both notations. Think about g of x being in the middle or in the inside, or if it's in this notation, it comes second, so that's what is going to go on the inside. Now you do have your functions here, which are going to work into one another. And you'll notice that with those steps, I do highly recommend writing out each of these steps. I don't just write it for fun. It tends to make a lot of sense when you write it this way. So it says f of g of x, g of x being this 3x here, now just says that we are going to replace every x with 3x in turn. So then we take your f of x, and anytime you have an x, you're just going to put a parentheses to make a gap. Now within your gap, this is where your 3x will go, because originally this function says 2x minus 1, but your x now is equal to 3x. And then we can simplify to make this 6x minus 1. So your f of g of x is equal to 6x minus 1. This is your new function. And if we did it again, but in reverse, g of f of x says we're going to take f of x and we're going to put it inside g of x. So g of f of x, which is 2x minus 1, is equal to, it used to be just 3x. Again, anytime you have an x value, you're just going to make a pair of parentheses. And this just says we're going to replace x with now 2x minus 1. 2x minus 1. And again, expanding a little bit, 6x minus 3. This is going to be your new function. G of f of x is equal to 6x minus 3. So now we have h of g of x. So again, this can be written as h on the outside, g of x on the inside. So we're going to take g of x, which is 3x, and now we're going to fit it inside h. H is x squared minus 1. So anytime you have an x, we're going to leave a gap, squared minus 1. This is where your x used to be, x squared minus 1, and we're leaving a gap, and we're putting in for x a 3x. Now, because it is a monomial term, we can go ahead and distribute in. If this was a binomial like f of x, so let's say it was f of x here, 2x minus 1, 2x minus 1, we would have to, we can't distribute in, instead we have to write double in FOIL. So in our case, 3 squared is 9x squared minus 1. So h of g of x is 9x squared minus 1. Now we have f of h of 7. Now on your inside term, we're supposed to be evaluating h of 7. Now if, for example, let's see, they asked us to do f of h, which I don't see here at the very beginning. So if they haven't asked us to create a function, so for example, if they already had us find f of h of x, we could use that new function, whatever it came out to be, to then plug in 7 into your x values. But let's say we're trying to shortcut that. Let's first evaluate where h is 7. So h being x squared minus 1, right? That used to be your your h. And as we do with your evaluating, we're just evaluating your x when it's 7. So we can insert that in. So we have 49 minus 1, which is 48. So that is h of 7. So when we're asked for f of h of 7, well, we're really now evaluating, well, h of 7 came out to be 48. It is this amount here. So that is what we get to now evaluate for f of x. F of x, we said, is 2x, and I believe it was minus 1, 2x minus 1 here. So leaving a gap as you normally would, we are trying to evaluate when x is now 48. So 2 times 48 will give you 96 minus 1 to be 95. So f of h of 7 is 95. So first evaluate, if you don't have a function created like these ones here, you can then evaluate by taking a look at the inside first, evaluating when h is 7, and then expanding whatever that number comes out to then plugging it in. This is why when we talk about your domains here, we want to focus on what the inside function was first, because that's the function that's going to be affected first. And then whatever number comes out, then it can go into the function at the very end. So let's try number 9. If we have h of f of 2a, we're going to evaluate we're going to evaluate first f of 2a. So f of 2a, this is when we have 2x minus 1, and we're replacing your x with 2a, which equals 4a minus 1. So this is f of a. So h of f of a is now equal to h of 4a minus 1. Then we can go ahead and evaluate h. H was, let's see, x squared minus 1. X squared minus 1, that is what h is. And this time we're going to say, well, x is really equal to 4a minus 1. So we can go ahead and put 4a minus 1 in. And now because it is a binomial, we aren't able to distribute in. Instead, we have to write 2 of this 4a minus 1. Let's go ahead and FOIL. We get 16a squared minus 4a plus 1 minus 1 on the end. We get 16a squared minus 8a. And unfortunately, these two ones are going to cancel because they're opposite. And I'm not sure how picky your instructor is going to be, but at this time, if you wanted to, you can go ahead and factor. So if we were to factor this out, we have an 8 and an a in common, leaving behind a 2a minus a 1. So depending on your instructor, they might allow you to leave it here. Others might allow you to leave it here. For me, I like the factored form, but we could say h of f of a, nope. What do we put 2a in? Is equal to one of these two. And there you have just a quick composite function of these. Again, big tidbit is just leaving a gap using parentheses for where your x used to be. As far as evaluating goes, evaluate the number on the inside first with that, and then start to expand outwards.